Astronomers scanning the night sky in July 2025 detect a faint streak of light, unlike any comet or asteroid within our solar system. Initial observations reveal 3I Atlas as an intruder from beyond the Oort cloud, its hyperbolic trajectory confirming origins in a distant stellar system. Telescopes worldwide pivot to track its rapid approach, capturing spectral data that hints at exotic compositions, volatile ices, and organic compounds unseen in local bodies. As data accumulates, patterns emerge. Non-gravitational accelerations suggest outgassing, forming a coma that shrouds the nucleus in mystery. Scientists debate its size, estimated at several kilometers, and its velocity, exceeding 30 kilometers per second. Archival searches uncover no prior detections, implying it evaded detection for millennia. The chapter delves into the detection methods, from automated surveys like ATLAS to follow-up spectroscopy, building tension around the object's elusive nature. Whispers in observatories grow. Is this a pristine relic from another star's formation, or something engineered by unknown forces? Yet, as coordinates refine, one fact crystallizes. It's not just passing through, it's diving deeper into our realm. But what hidden forces propel it faster than gravity alone can explain? Trajectory analyses reveal 3I Atlas's path as a slingshot through the solar system, brushing past Mars before veering sunward. Orbital mechanics experts model its hyperbolic orbit, noting deviations from Keplerian laws, subtle thrusts that alter its course unpredictably. Data from Mars orbiters like ExoMars capture close-up images during its flyby, showing a fragmented nucleus and jets of sublimating material. These non-gravitational forces, akin to the Yarkovsky effect but amplified, suggest internal activity. Ices turning to gas under solar radiation, propelling it like a natural rocket. Simulations predict perihelion at approximately 1.4 astronomical units. Yet discrepancies in velocity raise alarms. It's accelerating beyond expectations, compressing timelines for observation. International collaborations pool resources, employing radio telescopes to probe its rotation and density. The narrative builds suspense through real-time data feeds, where each update unveils anomalies. Unusual water vapor emissions detected by space probes, hinting at a planetary formation. A time capsule from an alien cradle. Comparisons to predecessors like 1I Oumuamua and 2I Borisov highlight differences. Atlas's brighter coma and higher activity level imply a fresher, less irradiated surface. Theoretical models explore ejection mechanisms, gravitational perturbations by rogue planets or binary stars, painting a picture of chaotic cosmic births. As it approaches, ground-based observatories detect isotopic ratios alien to our sun, fueling speculation about panspermia. Could it carry microbial remnants from extraterrestrial oceans? The chapter weaves in historical context of interstellar objects, emphasizing how rare detections challenge our understanding of galactic dynamics. Tension mounts as data hints at a possible binary nucleus, suggesting a violent past collision. Crimson, if it's from another star, what cataclysm hurled it into the abyss and toward us? As solar heat intensifies, 3I Atlas awakens, its icy mantle sublimating into a vast coma that obscures detailed imaging. Ultraviolet observations from space telescopes reveal ionized gases spraying outward, creating a tail stretching millions of kilometers. Anomalies persist. Irregular brightening events suggest explosive outgassing, fracturing the surface and ejecting debris. Chemical assays detect unexpected compounds, sulfur dioxide and possible hydrocarbons, raising questions about its formation environment. Probes like JUICE, repositioned for opportunistic flybys, capture high-resolution spectra, unveiling a dynamic interior possibly honeycombed with voids. The narrative explores the physics of cometary activity, from thermal stresses to radiation pressure, building dread around potential disintegration. Historical parallels to comets like Ison, which vaporized near the sun, underscore the risks. As it vanishes behind the sun from Earth's view, indirect measurements via solar-wind interactions provide cryptic clues. Scientists monitor for seismic-like events within the nucleus, hinting at structural instability. The coma's expansion accelerates, veiling secrets that ground instruments strain to pierce. Okay, will the coma shield it from the sun's fury, or herald its total annihilation? October 2025 approaches, and 3I Atlas nears its closest solar encounter. Velocity peaking, loss. Debates rage over survival odds. Some predict a spectacular flare-up visible from Earth, others a quiet fade into vapor. As distance shrinks, anomalies intensify. Unexplained velocity spikes suggest asymmetric outgassing or hidden mass. The sun's magnetic fields entwine with the comet's plasma tail, creating electromagnetic disturbances. Tension builds as the clock ticks toward October 30th. What unforeseen event might occur at the moment of truth, altering our solar system forever? Post-perihelion, if 3I Atlas endures, fragments may scatter, offering debris for future analysis. Simulations forecast possible outcomes: total sublimation leaving a ghostly dust cloud, or survival as a diminished husk outbound. Earth-based radars prepare to scan for remnants, while missions like ESA's probe concepts envision sample returns. The narrative probes scientific windfalls. Analyzing ejecta could reveal interstellar chemistry, testing theories of galactic chemical evolution. Comparisons to Borisov's water vapor emissions highlight potential for detecting biosignatures. Yet, risks loom. Debris fields posing hazards to inner planets, or atmospheric entries creating meteor showers. As it recedes, fading signals challenge tracking, leaving gaps in data. The chapter builds suspense around delayed observations, with solar conjunction delaying confirmations. Unresolved questions about its acceleration persist, fueling exotic hypotheses like dark matter interactions. It disintegrates, what lost knowledge vanishes with it into the solar winds. The implications of 3I Atlas extend beyond our sun, reshaping astrophysics. Its study refines models of interstellar object frequency, suggesting the galaxy teems with such nomads, perhaps one per year traversing our system undetected. This prompts reevaluation of solar system isolation, with potential for contaminant exchanges between stars. The chapter explores broader mysteries, how such objects inform exoplanet formation, or challenge dark energy theories through velocity anomalies. Collaborative efforts, from amateur astronomers to AI-driven surveys, accelerate future detections. Spectral data may unlock clues to universal element distribution, bridging cosmology and chemistry. As narratives of past visitors resurface, a pattern emerges. Each interstellar intruder peels back layers of the unknown. Yet, atlases gear up for surveillance. The chapter synthesizes the journey, emphasizing how 3I Atlas exposes our observational limits. Vast swaths of space remain uncharted. As it fades into the outer darkness, potential for rediscovery dims, leaving a legacy of intrigue. Debates persist on its true nature: comet, asteroid hybrid, or something undefinable. The narrative closes the arc with reflective tension, underscoring humanity's fragile grasp on the cosmos. Each data point, scrutinized anew, reveals inconsistencies that defy resolution. What final secret does 3I Atlas withhold, echoing eternally in the silence of space?